Continuing on with this lesson, this is Evaluating Limits Algebraically, Part 2. In Part 1, we saw how simple it is to evaluate a limit if you can use direct substitution. There's no problems with the graph. There's no deleted points, no asymptotes, etc. Now we're going to see when it's a little harder to evaluate algebraically, but with algebra, it makes the task quite simple. So continuing on, let's see, we're at number 7. Let's find the limit as x goes to 5 of x squared minus 25 over 3x minus 15. Always try direct substitution. So if I try this direct substitution with this problem, I get 15 minus 15 in the denominator. That's 0 over 0. Uh-oh, I don't have a value. 0 over 0. This is called indeterminate form. I can't tell what the limit is because it's 0 over 0. Now with algebra though, I can evaluate the limit because there's a hole in this graph at 5. So if I use some algebra, in this case it looks like if I factor and cancel, I can then substitute in, and now I'll know the limit as x goes to 5. So let's give that a try. If I factor it, notice that x minus 5 is both in the numerator and the denominator, and that's what was causing 0 over 0. I end up with x plus 5 over 3. Now if I substitute, I have 5 plus 5 over 3, or 10 thirds. The limit as x goes to 5 of this rational function is 10 thirds. There's a hole at 5 and 10 thirds. Okay, number 8. The limit as x goes to 0 of the square root of x plus 3 minus root 3 all over x. Again, I try substitution, and I end up with root 3 minus root 3 all over 0, which is 0 over 0, indeterminate form again. Indeterminate form. Or it's just an indeterminate. So I have to try algebra. In the algebra in this case, the technique to use when you have something like this is to multiply numerator and denominator by the conjugate. And notice, if I distribute the two binomials up in the numerator, I'm going to get the difference of two squares. So I'm going to have the limit as x goes to 0 of x plus 3 minus 3. Do not distribute the denominator. Simplifying that, I have x over x, square root of x plus 3 plus root 3. See why I didn't distribute the denominator? Because now I can cancel what's causing 0 over 0. Substitute in x equals 0 now, and I have 1 over root 3 plus root 3, and the limit is 1 over 2 root 3. Alright, let's see if we have another one. Okay, one more. Another technique. The limit as x goes to 0 of 1 over, let me bring that down a little bit, of 1 over x plus 4 minus 1/4 all over x. Substitute in 0 over 0. You do not have to write 0 over 0. I just wanted you to see that it was indeterminate form and that 0 over 0 was not the limit. So we have to do some algebra. In this case, since I have a complex fraction, I'm going to clear the complexity of this function. And I can do that by multiplying top and bottom by the LCD. Okay, this is a nice technique because it's going to clear up very nice indeed. Because when you distribute the first term, the x plus 4's cancel, and you end up with 4. When you distribute to the second term, the 4's cancel, and you end up with minus x minus 4. Be sure to distribute that negative. Again, do not distribute the x or the 4 to x plus 4. Just rewrite it. Okay, so this is negative x over 4x times x plus 4. The x's cancel, and I have negative 1 over 4 times x plus 4. Substitute in x equals 0, and I have negative 1 over 16. Alright, so those are the three techniques that you're going to use most often. Before I end this lesson, I'd like to work with the properties a little bit, and then we'll do a little bit of trig. The properties, remember, are on page 59. Alright, suppose, this is number 10, suppose that the limit as x goes to 6 of f of x equals 3, and at the same time, the limit as x goes to 6 of g of x equals negative 1. Note they're both going to the same x value, which is important. I want to find the following. The limit as x goes to 6 of f of x plus g of x. I'll just put it in brackets to show you that I'm finding the limit of both of those. Well, that's simply, if you look at the properties of finding the limit of f of x, which is 3, as x goes to 6, and g of x is negative 1, add them together and you have 2. That's the sum and difference property. Okay, number 2, or should I say B. Let's look at the product property. Alright, the product property for limits just says that if you find the limit of f of x, which is again 3 as x goes to 6, and g of x is negative 1, the limit is just their product. C, the quotient, f of x over g of x. As long as the limit as x goes to 6 of g of x doesn't equal 0, this is going to exist, and it will be 3 over negative 1, which is negative 3. D, the limit as x goes to 6 of 4 times f of x, a constant 4. You just multiply 4 times the limit of f of x as x goes to 6, which was 3, and you'll have 12. And then the last one, the limit as x goes to 6, and you have a function squared. Find the limit inside that square, inside the parentheses, which is 3, square that, and it's 9. Those are the properties. Okay, now trig. The limit as x goes to pi over 3 of the sine of x. Substitution. We have the sine of pi over 3. Time to remember your triangles. What's the sine of pi over 3? Draw a right triangle. Sine is opposite over hypotenuse. Root 3 over 2. And the last one, the limit as x goes to 2 of the sine of pi x over 2. Substitute. The sine of pi, think about the quadrantals, the sine of pi is equal to 0. If I haven't given you back your trig cards, you just need to remind me, because we're going to be using a lot of trig in this section and from now on. Well, this is the end of part 2. Well, wait a minute, I would like to do a little review though. Let me do a review before I end part 2. Maybe we'll call it a summary. Number 1, substitution. Always try this first. substitution fails, try to factor, try factoring, and then simplifying. Number 3, when substitution fails, rationalize the numerator or denominator. That's by using the conjugate. Number 4, when substitution fails, simplify if a complex fraction. Alright, so always try substitution first. Sometimes when students start doing the homework, they forget about that. When substitution fails, try factoring and then simplifying, or rationalize the denominator and numerator by using the conjugate, or simplify if